All right, so in this problem, we've got Andre who is trying to figure out how he needs to cover a garden. He knows it is 5 feet wide, so we might label this as the width. But then it's 12 feet long, but then they're going to add a couple more rows of vegetables, so more veggies, but we don't know. We don't know how much that they're going to add on. So it's going to be a certain amount long. It's going to be 12 plus x long. Okay, and so we need to write two expressions that model the area of Andre's garden. Remember, we find the area by multiplying the length. Multiplying the length by the width. So again, this is our length. Length, hooray. But we don't know our length totally yet. And what I want us to do is write two expressions to model this. So, and then we're going to explain how we generated that. We're going to show some work here, and then we're going to actually show the work down here and explain it so it's ready to go on the computer. So let's think about this. We have area, right? The area is given by the length times the width. And remember, we can switch that order around all we want. So I already know what the width is. The width is 5. So I just have to multiply the width by the length. The length is a little more uncertain. The length is 12 plus whatever we add on here, right? 12 plus x. So that means I got to do 5 times whatever 12 plus x is. And remember, that's what that means right there. This means 5 times all of 12 and x. Not just 12, not just x, both of them. So again, we might need to use, it looks like we're going to need to use what we know about the distributive property here. You can multiply that outside number by both inside numbers. So here's what I can do. I can say, okay, well, it looks like I already have one expression because it said write two expressions. So here's one of the expressions. Nice. All right. Let's keep going. So I know I just do 5 times 12. That gives me 60. And then 5 times x would be 5x. So there's the other expression. So now I just got to take this down here, put it in my box, enter it, keep track of my tools that I'm using so we can practice like we're using it on the computer. And here's what I need to do. Okay, so I need to explain this. It says write two expressions to model the area and then enter them in a box and explain how you do them. Okay, well, let's start by entering them. So my first expression, if I'm typing this in, first expression, then I would type 5 parentheses 12 plus x. And then I would press enter and I would type second expression. Remember, I'm pretending like I'm typing on a computer. I would get 60 plus 5x. Now I just have to explain how I got those, because it says write two expressions that model the area of Andre's garden. And then we need to explain. Remember, the math writer's CFS needs to be used anytime you see the words explain, how you generated the two expressions. So the first expression I found my first expression by knowing, well, how did we know to make it multiplication? By knowing, that's because we knew length times width. By knowing that area is found by, and you can actually write this in, length times width. If you know that, you can write that down, absolutely. So there's a fact, stated a fact about our work. This is kind of our assertion right here. So that's kind of our assertion. Here's a fact. Here's another fact. How did we get our second expression? I found my second expression by knowing that you can multiply. Well, can you tell me about this outside number by those insides? Think back to our distributive property long-term memory chunk we know. So I could say I found my second expression by knowing that you can multiply the outside term, by both inside terms to make a new and equivalent expression. And so that's what I would need to write. And this is what would go on the computer. A lot of stuff to get to, so you got to move through these problems pretty quickly when you get to Park and see if you can remember back to this stuff that we worked so hard in class on.